Good morning or good afternoon, everybody. Today we're going to be talking about electron configurations. So if you could make sure that you're on page 5 with us, that would be great. So first thing that you have to write down for number 1, what is an electron configuration? So it just tells us basically how the electrons are arranged in the atom, and it's going to exist for every single element. So every element that we see on the periodic table has its own electron configuration, so just arrangement of electrons there. So today you're going to see all these different types of electron configurations. So you can see hydrogen has its own 1s1, helium has its own 1s2, you can see lithium, you keep adding. This is very similar to the activity that you guys did yesterday. So if you remember that little pattern puzzle that we did, with that pattern puzzle, you saw those same kind of patterns related to these electron configurations. Remember, all these atoms are going to have the same number of electrons as they would in a neutral atom. So hydrogen just has 1 proton, so it's going to also have 1 electron in that atom. So in addition, going on a little bit. So with these, you don't have to write anything down for this one, but just look up here. Yesterday we discussed ground state versus excited state and where the electrons have the most energy. So is this the first energy level of our Bohr model? This one has the lowest amount of energy. As you move further and further away to these energy levels, which are further and further away from the nucleus, these electrons are going to have more and more energy. So nothing to write down there. Also remember, each energy level is going to have a certain number of electrons that it can hold. The electrons in the first energy level will just typically hold 2. And then it goes 8, 18, and then 32 from then on that they can hold for their maximum energy levels. Now, back to your packet. You don't have to write this down yet. We're going to talk about these things real quick, and then we will write these down. So just listen for just a moment. There are 4 sublevels that you saw yesterday in the pattern puzzle activity. These are kind of the patterns that you should know for these. The shapes, okay, you'll have the S, the sphere shaped. You'll have the P, the dumbbell shaped, kind of the orbital shape of where you're going to find those electrons. We have the D shape, kind of the funky shape there. And then we have even the funkier shape here. This is more like the 4-leaf clover, I guess. And this is more the funky shape, the weird orbitals with 14 electrons with that 4th sublevel. For here, the first one, S, the maximum electrons that you can have for S is going to be 2, and a lot of you saw that in the activity yesterday. P, max electrons that you possibly can hold are going to be 6, D can hold 10, and F can hold 14. That means that for F, you can actually have 7 different lines, 7 different orbitals for those electrons. For D, you can have 5 different lines for those orbitals, and then for P, you could have 3, and S, you could have 1 orbital here. So let's actually write down and see what this looks like on your table on page 5, I believe. So, looking here with me, we're going to fill this out. So we just saw the 4 sublevels, which you're just learning. The first sublevel that's going to be filled is going to be the S sublevel. So we're all going to write S right here. The next one is P. Okay, you're going to write P in that second one. You can kind of see that. Sorry, I put it off for us. SP. We're going to have D. And then we're going to have F here. So S, P, D, and F. Those are our 4 sublevels that we have to know. Now, the number of orbitals, okay, which is the number of lines. So let's write on the side a little bit of what's going on here. Anytime you have an S orbital, if you think back to yesterday on your little sheet, you always had S with 1 line. Okay, so 1 line, that's going to be 1 orbital. So we're going to put a 1 right here. So think of it this way. It's S with a line. Okay, that is how many orbitals for the S sublevel. For the P sublevel, we had P, and we actually had 3 lines. So we're going to put P, 1, 2, 3 lines, no matter what. You always have to write those lines. That means that there's 3 sublevels there. For D, okay, with D, you had D yesterday you saw a lot of, and then you had 1, 2, 3, 4, 5 actual sublevels for D. So 5 Lastly, we had F yesterday. F, you actually have 7 different lines for F. So 7 max orbitals that you can fill those electrons. So this is the space and those letters. S tells us, again, it's sphere-shaped. P tells us it's double-shaped. D is going to tell us that it's a 4-leaf clover. And then F is going to be kind of that funky shape. Okay, so this tells us how many lines we always have to put next to them. And so we always put 1 next to S, 3 next to P, 5 next to D, and F always will have 7 of those lines, those orbitals. Okay? Max number of electrons in the sublevel then. So if you look here at the S sublevel, okay, you can see S with 1 line. The maximum number of electrons that can be held on that line are going to be 2. So we're going to draw in our 2 electrons, and we're going to put 2 electrons max in that S sublevel. Then let's go to P. P, it has 3 lines. Each line can hold 2 electrons. So you're going to put 1, 2, 3, 4, 5, and 6. Yes, we have them going opposite ways, and I will talk about that in a little bit. So maximum of 2, 4, 6 electrons in the P sublevel. D. With D, you have 1, 2, 3, 4, 5 lines. Again, remember 2 electrons can go in each line. So we're going to fill them in. 2 in each line going opposite ways. Those are our little electrons. And that means that we're going to actually have 2, 4, 6, 8, 10 maximum electrons that we can actually have in that sublevel. Because remember, each one of these little arrows is representing an electron. For F, again, there's 7 orbitals here, 2 in each one. We're getting good at this. You don't have to draw them in. But there's going to be 14 maximum electrons that can be held in that F sublevel. Okay? So what is this SPDF stuff telling us? It's telling us kind of the shape of where these 3D locations of where these electrons are actually going to be placed. So if you think of an S sublevel, the electrons are going to be found in some sort of spherical 3D location. So we're going to put shape of orbital as a sphere here. Then P, okay, so P, and we can move this over a little bit so you guys can see. So sphere, we're just going to put a little round sphere here. That's the shape of the orbital for the S sublevel. For P, P is going to be kind of a dumbbell shape. I'm trying to think of what other people have thought. I always call it dumbbell, but you might have a different name for it. Okay, that's kind of what the 3D location looks like of where you're probably going to find, if it's in the P sublevel, what that shape of that orbital is going to look like. Then for our D orbital, if I can talk, D sublevel, we're going to have a 4-leaf clover. That's a little bit easier to draw. So the 3D location is a 4-leaf clover. Anytime that it's going to be in the D sublevel. For the F sublevel, it's going to be kind of similar to the D, but a little bit different. And I call it funky. You can call it whatever. I don't know, as long as you know what it is. But it's kind of like a double funky in a way. Oh boy. All I know is there's 6 little things going on there. So 1, 2, 3, 4, 5, 6, and kind of a funky shape there. Just understand it's a lot more complex with some of the other ones than the other ones. So recap. We have 4 sublevels here. Okay, we have S, P, D, and F. S is going to hold maximum of 2 electrons. P is going to hold 6. D is going to hold 10, and F can hold 14. These shapes correspond to the sublevels. So if it's in the, we say an electron's in the S sublevel, it's going to be in the spherical kind of shape 3D location. If it's in the P, it's going to be the dumbbell. D is going to be in that 4-leaf clover kind of area. And then F is kind of going to be in that funky kind of shape compared to the other ones. So moving on. With this is the periodic table labeled according to the electron configurations. Since they have these beautiful patterns, we have a nice way that can help us figure out the arrangement of electrons for every single element. So if you look at this with me, S, okay, all the S sublevel are going to be right here. You can see the P is going to be over here. And then the D is going to be right here. You don't have to write anything. You don't have to do anything yet. I'll tell you when to start writing. But this is on your paper, so just take a look at it so far. It's not color-coded because we don't get colored copies, but you can at least see what it looks like from up here. So you can see the S, you can see the P, you can see D, which is kind of in the middle, and then down here, these guys are kind of the F subblock. So we're going to write a few things. The order of them goes, and we can write this together. So the order goes S, write this with me, P, D, and F. Remember that. So S, we're going to go over here. We're going to put a big 1 right here. So whenever, it's kind of like reading a book. It goes 1S, okay, 1. Then you go to 1S, 2. You read the book here. Then you come back over here. After you've read that, you come back to the left side. Now you are at the second energy level. It's 2, 2S, 2, and then now we're at P. So 1 goes with S, 2 goes with P, so put a 2 right here. 2 starts the P block. Okay, so 1 starts the S block, that's convenient. 2 starts the P block. You read through that. 2P1, 2P2, 2P3, 2P4, 2P5, 2P6. Okay? After you've done that, you're going to read the book. You come back over here. After 2P6, you're now at 3S1. Nothing's here, no D block yet. Then you're at 3P, fill all those. 3P6, come back over here. You're now at 4S. This is the difficult and problem area. People get confused. You're at 4S, so you fill the 4S sublevel and energy level. Now you're at the D block. What energy level are you filling? The third. So next to S, you have 1. Next to P, you have 2. Next to D, you will have the third. So 3 starts the third energy level right here. So this is the hardest part for a lot of people. You go from 4S to 3D, which is kind of awkward. So you go to 3D, and the weird awkward part over here is that you're also going to go to 4P. So you now start 4P, you fill all of those. Then you go to 5S. It's kind of strange again. You go fill 4D after that. You fill 5P, and then you will fill 6S, 5D, and you keep going. Now, we haven't gotten to the last one. We had 1S. We start the P with the 2. We start D with 3, and then last one. You start 4 at 4PF. So put a 4 in front of the P block, or the F block, sorry. So F block is 4, and then this one's going to be 5. So that's how I usually label those. We're going to do that right now on another piece of paper. So grab your, pause for a moment, and if you could get your periodic tables out, that would be great. So pause for a moment, get those periodic tables out, and we're going to label those together. And you'll eventually color those. Maybe. Give me 1 second. I'm trying to figure out my link. Oh, there we go. All right, so you have your periodic table hopefully out in front of you right now. We're going to kind of color and label this guy so that you can continually use this throughout this class. So here we go. We are going to write the energy levels first. So the energy levels kind of correspond to the distance the electrons are from the nucleus. So first energy level, these guys are going to fill the first energy level, then they're going to eventually fill those lower ones. So we're going to put a 1 here, 2, 3, 4, 5, 6, and 7. So those are our energy levels on the outside. The next part, let's actually label those as their energy levels. So if you're wondering what an energy level is, remember it's just that kind of ring from that Bohr diagram that we're talking about. So those are all energy levels. 1, 2, 3, 4, 5, 6, 7. Then we have to go and we're going to label our S block, our P block, D block, and F block on here. So right here, you're going to box this part kind of in. The first 2 kind of columns right here, these are your S block. Okay, so put S. And the maximum number of electrons that can be held here are 2. The only weird one is the helium over on the other side. I also want you to kind of box this guy in. He's technically part of the S block, so include him. The other ones here are not part of it. It's just that helium that's part of the S block. Okay, so it goes 1s1, 1s2, back at 2, 2, we're still in the S subblock, 2s1, 2s2. Now, we got to figure out what starts this. So this is now the P subblock. So we're going to go like this. We're going to label this P. Max number of electrons, remember, max number of electrons that can be held in the P subblock are going to be 6. So we're going to put a 6 as a superscript right there. And then, going a little bit further, we now have 2s1, 2s2 right here. We're going to put a 2, remember? P subblock starts with a 2, okay? The first subblock starts with a 1, okay? Start with a 1 here. Then we go to fill our S's. We get to 2. Then we get to P. With this P subblock, it always starts with 2, okay? So this would be the second kind of period. 2P1, 2P2, 2P3, 2P4, 2P5, 2P6. Okay, then we're going to come back over here. 3s1, 3s2. Back over here. This would now be, some of you might want to write this in the corner, this would be the third kind of block there. Okay, so that's the third area of the P block. So it would be 3P1, 3P2, 3P3, 3P4, 3P5, 3P6. That's how we read it. That's how we fill the energy level. So that's the third energy level of the P subblock. Then you come down here. It's going to be 4. How do we read this? It's S. 4s1, 4s2. This is where, again, big change happens. So this is where we need to kind of box these in. This now, right here, is going to be called the D subblock. So the D subblock, and D subblock can hold 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. Max number of 10 electrons. Let's write up here what we've just done so far. We haven't gotten to the F, but let's reiterate what's happening. So S, again, can hold maximum of 2 electrons. P, hopefully you can see that. P can hold 1, 2, has 3 orbitals, maximum of 6 electrons. And you can see that by counting out 1, 2, 3, 4, 5, 6 electrons there. D, 1, 2, 3, 4, 5. And you can see that 10 electrons can be held in D. Okay? So, going a little bit further, we haven't gotten to F. So if you've read this, this is the tricky part. This would be 4s1, 4s2. This is where 3 starts. So I want you all to mark this as 3. I want you to mark this as 4. I want you to mark this next one as 5. Next one is 6. Note that these do not correspond to the same numbers. That's confusing to people. Okay? They're slightly different. They fill in these kind of weird patterns. So it goes 4s1, 4s2, 3d1, 3d2, 3d4, 3d5, 6, 7, 8, 9, 10. I got ahead of myself. 10. So 3d10 is right there. After 3d10, take a moment and write these with me. It's going to go 3, 4, 5, 6, and 7. So all of those are going to be kind of the same P block area. And you may be saying, what is she talking about? But once we color it, I think it will help you see the differences here. So as you can see again, 4s2 ends right here. That goes to 3d. This is how the electrons fill. It goes 3d. You fill all of 3d. Then you don't go to 3p. You go to 4p. You fill all of 4p. Then we come back over here. 5s. Then you go to 4d. 5p. P, you fill all of those. And then the weird part, so brace yourselves, please. Okay, this is where you need to pay close attention. After 6S, you see these kind of dotted lines here. I want you to draw an arrow pointing down for both of these. Point an arrow going down for both of those little lines right there. What that means is, after you fill 6S2, so after you fill these two right here, you're going to go down and fill this guy before you come back up. So that means you fill 6S1, 6S2, then you say, okay, I don't go over here yet. You slide down, and then you fill these guys. These guys are the F sub-blocks, so I want you to kind of block them in. I want you to put F, and I want you to put that these guys can hold 14 electrons there. So 14 maximum electrons. You're going to fill these guys, but what do they start with? Remember, S starts with 1. P starts with 2. D starts with 3. That means F starts with 4. So this is going to start with 4, and then this one's going to be 5 below it. So 4 and then 5. That means up here, F, 1, 2, 3, 4, 5, 6, 7. You can have a maximum of 14 electrons. So count to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 electrons can maximum fill that F sublevel there. Okay, so you're going to get time right now to color the periodic table according to those sublevels. So take a moment and color, pause the video, and I will have the substitute post the colored periodic table for you. So take some colors, label the sublevels, label this section, okay, P section, D section, and F section, and that will help us with our next step, okay? All right, welcome back. So what we're going to do right now, I want to pick up on the bottom of page 5. So pick up on the bottom of page 5 with me, please. We're going to go through using our knowledge now. Hopefully you're not too confused. You might be a little confused. But we're going to use our knowledge and our beautiful labeled periodic table here. So hopefully you had a chance to label yours. You got to label the S subblock, the P, the D, and then the F subblock. Do not forget that this is the 1 always. Then we have 2 that starts this, 3 that starts that, and 4 that starts the F sublevel. So what does all this mean? Okay, we're getting there. This right here, this means the energy level that it's filling. Remember, it always fills the first energy levels, and then it will fill those outer energy levels. So number 1 is energy level. Okay, so write energy level for number 1. That number right there. The S, the S, P, D, and F, you've heard me say that numerous times. That's going to be what the sublevel is. That tells us the shape of the arrangement of the electrons. Are they in a sphere? Kind of the orbital that they're in. Are they in P? Are they the dumbbell, the funky kind of shape? Or are they just kind of in that flower-looking shape? So this tells us kind of the shape that they're in. This tells us the location and how close they are to the nucleus. And then lastly, what's that little arrow represent? The arrow represents the electron. And the maximum number of electrons you can have in this whole thing, what the line is the orbital. So each line is an orbital, and it tells us the maximum number of electrons that we can have in that little section. Okay, that's one way of writing it. This is called the orbital notation. Another way that you can write it as 1s2, 2s1. These superscripts, okay, that's the only new part really here. This still means, so label this with me, this still means energy level. This still means sublevel. But this means the number of electrons. So the superscript is telling us the number of electrons there. Same thing with this superscript. This superscript is saying just 1. You don't have to fill all of them. Okay? You can actually add these up. 1, 2, plus 3. So total of 3 electrons, which means if this is a neutral atom and it has 3, it wouldn't be hydrogen that has 1. Helium has 2. Lithium would have 3. So this one right here would be the electron configuration for lithium, because we know the superscripts, the number of electrons, are going to add up to the actual number of electrons there. Okay, so moving on a little bit. Yours might look a little bit different. So this is what yours looks like. So with yours, you can see these are all, if you added all these together, so 6, 7, 8, 9, 10, 11, 12, you could look at your periodic table and determine what element that would be. And they have an atomic number of 12, which would be magnesium. These, again, would tell you what the energy levels are. So one, first energy level. Second, gets a little bit further away from the nucleus. Third, even further from the nucleus. And then the S, P, D, and F tell you the shape of those orbitals. Okay, and we've already labeled this, the energy level, sublevel, the electron there, and then the orbital which it's located. Okay. Now, there are some rules for writing electron configurations. Okay, some of you saw some of these rules yesterday, and you were wondering, why do they fill, or why does it have that pattern? So these are the rules. I'm not going to make you actually memorize the names of these people, but this just helps us understand why we do what we do when we're filling in electron configurations. So these are our 3 rules. I want you to write these down with me, please. So the first one is the Aufbau principle. Fancy word. You don't have to memorize the Aufbau principle part. It's just telling us, if you can't read it very well, electrons occupy the orbitals of lowest energy first. That means it's always going to enter the first energy level, then the second energy level, okay, fill that next sublevel, so the first sublevel, then the next sublevel. It's going to keep filling those. I call this the lazy tenant rule because
Keely Cannon, please come to the attendance office.
If you're a tenant, you fill the bottom level first, okay, first energy level. Then you go up to the second energy level. Then if those are full, then you have to go to the third one. So it's kind of, you always have to go in this pattern. That's how electrons always fill. You won't fill those outer energy levels unless you fill the inner ones first. That's the Aufbau principle. Okay? If you need to pause it, you can. Then, Pauli exclusion principle. That one just tells us these electrons are going to always have opposite spins whenever they're on the same orbital. So anytime that you draw an orbital, a little line, you're always going to have opposite spins of electrons. Okay, you can never have them going the same way. So those electrons always need to have those opposite spins. If they're in the same orbital or in the same space, they will not be spinning the same direction. Okay, so that's Pauli's exclusion principle. It's really just saying that they have to have opposite spins. So you don't have to write everything. Just understand electrons have opposite spins when they're paired in that same orbital. Okay. Last one, Hund's rule, my favorite one, the bus seat rule. So what this one says is electrons occupy orbitals of the same energy in a way that makes the number of electrons with the same spin direction as large as possible. And you're saying, what does that mean? Okay. Yes, it seems very confusing. But what it really means is, which you might not be able to see very well, that when you fill a 2s or a 2p, some of you saw this yesterday, so you can kind of see my drawing over here. You have to always write those 3, no matter what, but you have to realize that they're going to fill a little bit differently. So how they fill, you're always going to have them fill individually first, always like that. It's kind of like if you get on the school bus and everybody kind of sits in their own seat, but then you're that person that walks on and everybody else already has their own seat. You're like, darn it, I have to buddy up. You have to find a bus seat partner, okay? So once all the electrons have occupied those orbitals, then they go back, and then they're going to have buddies, okay? And they always have to have the opposites, the spin direction, going the same way until they buddy up, okay? So always fill them first. I'll show you it again. So fill them going the same direction, like that, first. Then you will go back, and then you will buddy up after that. So that is called Hund's rule. If you guys need to pause for a moment to write those down and go over those, you may. I'm not going to quiz you on those, but we're just going to use those in the next section. right, moving on. We are on number 5 on page 6. So page 6, if you've kind of gotten where we're at. So on page 6, we're going to go through one method. Have your periodic table in front of you. I'm going to show you how to use your periodic table as we go through these right now. So first one, I want everybody to find lithium for me. So find lithium. Put your finger on lithium. It's atomic number 3, I believe. So you find lithium. It's right here. Now, this tells you it wants you to write it in standard notation. We typically won't write them a lot of times in standard notation, but I want you to know how to, so we're going to practice it at least once. So with standard notation, you're going to use superscripts. Okay? So I'm going to show you each method and make sure you note the differences as we go through these. So with the standard notation, we have lithium. Okay, and with lithium, you are going to then go back up. Always start at the top. Remember, they always fill the first energy level. So this is the first energy level. This is going to be S. So we're going to write 1S. Okay, write a 1S there. You're going to have to go back. Do we have to fill 1S1? Yes, we have to fill 1S1. Do we have to fill 1S2? Yes, we have to fill 1S2. Remember, maximum electrons can be 2. Standard uses superscripts. So we write 1S2. Then, going a little bit further, we have filled 1S1, 1S2. Now, what energy level are we filling? We're now going to the second floor. We're going a little bit further away. We're going to the second one. So the second one is going to be the second energy level. Okay, then here we go to 2S1. You do not fill 2S2, you just fill 2S1. So 2S1 right here, it's going to fill it up a little bit, and then you are done. Double check. 2 plus 1. Oh, I forgot. Sorry. It's an S there. 2S1, because it's the S sublevel right here. So 2S1, we filled up 1S2, 2S1, and we stop right there. Do not go any further, because that's where we kind of read our book. 2 plus 1 is 3. The atomic number for lithium is 3, so we know that that's going to be correct. All right, everybody, let's find aluminum. Atomic number 13. So once you find aluminum, we're going to have to go through a lot of different energy levels in order to get to aluminum. So let's go 1S. We're going to go 1S2. Then we're going to fill the 2. 2S. We're going to go through both of them. We have to fill both of those right here. So 2S1, 2S2, we fill both. Superscript 2. This is where people get lost, so stay with me. 2S2, we go across, we read our book. What starts the P? Remember, 1 starts S, the P sublevel starts with 2. So that's our second energy level. We're going to put 2, 2P, 1, 2, 3, 4, 5, 6. We're going to fill all of those because we're not to aluminum yet. Maximum number at P can be 6, remember. So we filled 2P6 all the way. We read the book, we go back to the next line. Then we go to the third energy level. Remember, this is the S sublevel, so 3S1, 3S2. We're going to fill both of those. Remember, maximum of 2 electrons there. 2S2, then we're going to go right here. Remember to go 2, 3. That's where people get kind of confused. So now we're going to go to the third one. And it'd be 3 what? What section are we in? 3P. We're not filling them all. We're just filling the first one. 3P1. Okay? So we've done 2 of those. We're going to do one more. And then we'll take a mini little break here for in a second. So next one I want you to find is bromine. So find bromine. Atomic number 35. This one's a waste, okay? So this one's going to have a lot of electrons. So we're going to follow the same pattern that we did with the other ones. Same thing. 1S. We're going to fill both of those. 2. We're going to fill 2S. 2. We're going to fill both of those. Then, remember P, we're in the P sub-level. We're going to fill all the 2, the second energy level. 2P6, Then we're going to go to 3, 3s, 2. Keep going. Oh, this is where we get confused. So we skip that D level, and now we're in 2, 3. We're in the 3P sublevel. We're going to fill all those guys. We're at 3P6. After 3P6, it's kind of weird. We come down here. We're now at 4S. We have to fill both of those. 4S maximum 2. Fill both of those. Remember the D if we start the D sublevel. We're going to start at, you should have a 3 here. We're going to start the 3 energy level. So 3D now. We get to write D, and are we going to fill all of those to get to bromine? Every single one of them, which means if you take my word for it, there's 10 of them, so maximum of 10 electrons in 3D. After 3D, make sure you have these marks. 2, 3, 4. So it's going to go 4 for 4P. We're in the sublevel P. We got to count over. 1, 2, 3, 4, 5. So we stop at the 5th one, and you should have 4P5. You don't fill all of them. You stop at the element that you got to. If you'd add all of those superscripts together, you should then end at the element of bromine. You should have 35 electrons then. Okay?